Good evening and good morning, guys. This is Kubernetes fundamental session. Today we are giving. So agenda for the today, we will cover. First, I will talk about myself. And second thing, we'll discuss about the container, why we are using containers. Third thing, we will deep dive in Kubernetes architecture and scalability. Third thing, we will talk about namespaces. Then we'll cover pods and nodes. And then we will talk about services, deployment, and deployment strategies. Then we'll talk about network policy and then securities. Why security is required in Kubernetes. Then we'll cover Q&A session if anyone have any question. So let's start. So first, hey guys, I am Sachin Sharma, and I am working as a lead DevOps engineer in Incova Innovation Labs, and I do have around 8.8 years of complete experience. And in Kubernetes, I am working from last 5 to 6 years, and I did Kubernetes administration side and also deep dive in development side. So that's about myself. So let's look about the containers, why containers are required. And this is the simple Docker flow. Like when any developer create a Docker file, then we use a Docker commit to build the Docker image. So with the help of Docker image, we can run the container, and after that, we can push that image in the Docker hub. And from the Docker hub, if we need to run any container, we need to just pull the image and spin the container. And so the question is why container is required. We can use VM as well, but container is necessary nowadays because it's lightweighted and we can run multiple application, and the boot up time is very less in the container, and also container is cost effective compared to the VMs. So we are mostly using container in Kubernetes, but if we want, we can use VM as well. So now the architecture and scalability of Kubernetes. So Kubernetes basically built from the main component in Kubernetes is the control plane, and control plane consists with the multiple object like etcd database and kube API server, kube control manager, kube scheduler, and cloud control manager. So etcd is a database. Etcd store all the cluster related information like our process, our object which are running in the Kubernetes. So those all the information is stored inside the etcd. And kube API server, we can say this is the brain of the Kubernetes. So in kube API server, like if any object needs to communicate with each other, so first communication will go through the kube API server, and kube API server will redirect that communication to a respective object where the object of API needs to communicate. Like a kube controller manager need to check how many replicas are running our cluster. So first it will go and check in the etcd. And if any we need to run any new pod or anything, so kube API server will check with the kubelet, like is there any everything fine to run any container or any pod. So it will kubelet pass the message to kube API server, and kube API server will connect to the controller scheduler. So scheduler will schedule the job and controller will control the process. So kube controller manager is responsible for the controlling all the process in the worker nodes. And scheduler, if we need to schedule any pod, so pod or any object in Kubernetes, so scheduler is responsible for that kind of thing. And cloud controller manager, when we are using any particular cloud, so that time this is very important object inside the Kubernetes. Kube proxy in worker, Kube proxy working in the worker node, and it's responsible for the networking related stuff like assigning the IPs and assigning the IPs and networking related stuff. Kube proxy is managed. Kubelet, Kubelet is the middleman, we can say. If any information required in worker node, Kube API server just go and ask Kubelet, hey Kubelet, I need these information. So Kubelet just provide those information to the Kube API server. And container runtime, we can use any container runtime, Docker, Podman, and there are a number of container runtime we can use. And this is responsible for the running the container. So this is the complete architecture of the Kubernetes control plane and worker nodes. So the request flow is like when any new kube, like we fire any command like kubectl get pods. So what happened in the background? First request will go to the API server. API server will check in the etcd how many pods are running in the current in our cluster. So it will just reply with the output. So this is the simple steps. And if we want to schedule any new pod, so that time the most of the component will be useful, like etcd to check like how many replicas are there, and kube proxy and kubelet for responsible to let API server know in which node we can deploy our pod. So namespaces. So namespaces is a very important thing in Kubernetes. Suppose we are working in a team, and we have a developer team, testing team, and other teams as well. And we have one Kubernetes cluster, and every team want to use the Kubernetes cluster to test their resources. So if developer team deploy few pods in Kubernetes, then testing team also want to deploy some other pods. And maybe if we deploy anything without any isolation, then what happened? Those resources will be deprecated. So that's why we are using namespaces. So namespace create the isolation inside the cluster. So it's just working as a virtual cluster. So developer team has their own namespace, and tester team has their own namespace, and they can use those namespace as per their convenience. But how to create namespace? So for creating the namespace, there is simple command, kubectl create namespaces. And if we did not define any namespace, then it will go and search in default namespace. So folks, we have to make sure if we are interacting with in Kubernetes, we have to specify namespaces. Otherwise what happened? You will not able to find your object or pod, your services, if you will not define the namespace. And if you want to get all the information about all the namespace, you just fire the command with -- all namespace. So now we'll cover nodes and pods. What is nodes? So nodes is just we can say bare metal server where our Kubernetes load is running. So and inside node, as we discussed previously, inside nodes, our pods, our services, our deployment, those things happening inside the node only. And pod is just a smallest unit of the Kubernetes where our container is running. Now, so suppose this is pod 1, this is the pod 2. Pod 1 has one container, and pod 2 has 2 containers. In Kubernetes, we can use multi-container pod as well. So those containers serve their process. Like we do have sidecar container, we do have init container. Init container, basically we are using init container lifecycle is when the main container will start, it will just initiate the requirement before and it will die before main container will start. So this is the life cycle of the yes, init container. And sidecar container provide the their their uses. Like we want to create some monitoring system and we want to fetch some metrics from the pod and deploy those metrics in some other server. So for that purpose, we can use sidecar container. So sidecar container can fetch those metrics real time and send those metrics to our server where we want to use those metrics. And kubelet is uh, responsible for the process. Like if anything happen in any container, then kubelet will notify the API server, hey, this is going on here, you need to take care of this thing. So according our setup, the API server will pass the message to the controller and controller will restart or kill the process and again spin the new container. So now we'll talk about services. So what is the services? So services basically working as a load balancer in the Kubernetes cluster. So we do have multiple type of services like cluster IP, node port, and load balancer service. So cluster IP service is responsible for internal communication inside the cluster, and node port service is open a port. Like we have incoming requests, so it will open a port, any port like 3 3000 3000 8 3000 30000 181. Any there is a range 30,000 to 32,000. It's 800 something ranges there for node port, which port we have to open for provide so incoming traffic can interact with our cluster. And services is a very important part in the Kubernetes. If because as you know, pod is not pod will come and up and destroy. That is the behavior of the pod. Pod is mutable and service is immutable, and service IP will never change. Once we create the service, and service is a highly available component in the Kubernetes as per the Kubernetes documentation. So if anyone wants to communicate with the pod, so first they have to interact with the service, and service will forward that request to the respective pod as per the label selector we are using in the service and pod. So if service will not there, suppose if service will not there, and we define our pod, then what pod will restart, then IP and IP will change of the pod, then we will struggle to communicate or complete our request. So that's why we are using service, and service will provide load balancing as well. Like if multiple requests will come, then service will redirect the traffic as per the availability inside the pod. And node port is responsible for outside communication. So node port will open a port, so our request can complete on that port only. And load balancer service we use when we are dealing with the cloud provider like AWS, Amazon, or OCI. Whichever cloud we are using, it depends on that. So deployment. So actually, what is the deployment? So deployment is the process to deploy our application inside the Kubernetes cluster. So there are two types of deployment in Kubernetes. One is normal deployment and one is stateful sets. So normal deployment we are using for deploying our application or our state, only our application side, and stateful sets we are using to deploy the database. there is one main difference between deployment and stateful sites. So in stateful deployments, what happened when we when we create the manifest file of deployment and fire the and apply that deployment. So what happened? It will create it will just match the desired state of the cluster. And it in background, what happened? Our controller will check with the help of the API server with the etcd what is the current state of the our Kubernetes cluster, and when we apply any deployment file, that will be our desired state. So it will match both desired state, and so it will match the desired state. So as whatever change will be there in our deployment manifest file, it will match the desired state. And stateful sets we use when we need to deploy any database services, like if we need to deploy MongoDB, MySQL databases, or other databases. So what happened in the background in stateful sets? So it will create one headless service, the one pod, and with each pod we do have a with every pod we do have the volume. So it will store all the data related that pod. So suppose if my pod went down in a stateful set, what happened? Because in normal deployment, suppose we have 4 pods. If one pods will die, then other pod will come up, but it will not maintain the state of the pods. Any pod will come. If we scale up, so it will add few pods. If we scale down, it will delete any pod. There will no state matter in normal deployment. But in the case of stateful sets, it will maintain the state and it will maintain the naming convention. So they have networking in a stateful set, queue proxy, volume we are using separately with the help of the headless service. So there are a couple of deployment strategy which we will cover today. So like rolling updates. So rolling update gradually roll out the changes to a deployment pod template by gradually replacing replicas with the new ones. So it will provide no downtime. When we use rolling update deployment strategy, the Kubernetes will gradually roll out the changes. Like we have 4 replica sets and we need to update our application via rolling update. So what Kubernetes will do? First, it will update one replicas and remove the one replicas. So it will gradually process will happen. So there will be no downtime, and it's very normal deployment strategy. By default, Kubernetes is using rolling update. Second is blue-green deployment. So in blue-green deployment, suppose we have a green blue environment where our application is running, and we want to deploy another version of application, suppose v2. So what we will do, we will create another environment which is green, and first we will test this environment is compatible and good or working as expected or not. Once everything fine, and then what we will do, we will just redirect our traffic to the green deployment. But this is the bit costly, because in this blue-green deployment strategy, we have to create another infrastructure, same as our previous infrastructure. So there will server cost or the infrastructure cost are there. And third is canary deployment. So canary deployment is same as blue-green deployment, but what we normally do in canary deployment, we just, because in blue and green deployment, we created complete infrastructure. But in canary deployment, we just redirect some part of the traffic. Like we do have the infrastructure, and in starting we redirect 10% of traffic, and we can test if everything working fine. Then we redirect the rest of the traffic to the new server or new version of the application. So now we will talk about the network policy. So network policy allow you to control the traffic. So like as you know, by default in Kubernetes cluster, any pod can communicate with each other. This is the default nature of the Kubernetes. And if we want to modify this nature, suppose in a pod we have some secrets or some information which we don't want to share with any other pod. So in that case, we will utilize the network policy. And what network policy will do? Network policy will isolate that pod, so that pod will not able to communicate with each other, and any pod want to communicate with that pod, so that will not happen. And that we can control with the help of the ingress and egress inside the network policy. So ingress we use to block or allow all incoming traffic, or uh, egress we can use to allow or block all outgoing traffic. So there are a couple of things which we have to take care when we define any network policy. So like ingress and egress, and there are one block from and one is to. From we are using for the ingress, and to block we utilize for the egress. And there are a couple of statements which we use in the network policy, like pod selector, which is applicable on the pod, and one is namespace selector, which is applicable for the namespace, and one is for IP blocks. If we want to allow or block particular IP, then we can use IP block, and one we can use from the port. We can define port as well, from which port we can allow traffic, and from which port we don't want any traffic. So those things we can define. But be ensured when we block any traffic or allow any traffic from the port, that time you have to specify one from or two block, so traffic can control by the network policy. So now we'll talk about the security practices. So in security, we will talk about role-based access control, role binding, service account, and admission control. So role-based access control provides the authorization for the Kubernetes API. So suppose we do have a Kubernetes cluster, and any user wants to communicate with your API and wants to create any object in your Kubernetes cluster, then they need to have a specific role, so they can do the respective work they want to do in your Kubernetes cluster. So for that purpose, we use role-based control access, or RBAC. And there is a cluster role as well. So role-based control access is applicable for the pod, or like if we need to define certain thing inside the pod, and if we want to make some changes or provide the authorization cluster wise, that time we use cluster roles. And role binding is an object that bind the RBAC to the particular user. So suppose we have created the role and we want to provide that role to particular user or service account. So that time we use role binding object and assign the role binding to that user or service account, so they can do their respective work inside the Kubernetes cluster. And now what is the service account? So service account allow process within the container to authenticate with the Kubernetes API. So what is that? So service account, suppose your application is running and your container need to communicate with the Kubernetes API. So for that purpose, we use service account. And for providing authorization for service account, we use role-based access control and bind the role and provide to the service account. So my service account can communicate with the Kubernetes API when it's required. And the final thing is admission control. So admission control is a process, I can say, after authentication. Like I just want to create a pod, and after authentication, it will change the API. So it can allow, deny, or validate my request, but after the authentication. So once my authentication is done, then admission control, we can use admission control to check or validate the request. And if we want to modify the API call after authentication, we can use admission control. And admission controller is defined by the administrator of the Kubernetes cluster. And also we can utilize some admission controller which is by default providing by the Kubernetes. Okay, so that's bring me to the end of this session. If anyone has any question, please let me know.
Sachin, give me a minute. I will read out the question to you.
Okay.
So we had a question like, what's the difference? This is by Dattatreya. What's the difference between VM and container? And can you mention any case study differentiating VM and containers? We actually had Siddharth who had replied. Maybe you want to have 3 environment isolated SQL servers running on same machine. It is faster and cost effective to use containers over VM. No need for hardware visualization. So
yes.
Your thoughts?
Yes, and also we use container because container is lightweighted. In VM, pre-installed binary and there is OS is required, but container is just bunch of the binary and it's used the host OS. And the use case is, suppose my application, I have an application which is running in the VM, and if I do have I just want to upgrade the application. So for that, I need to use another virtual environment of VM, because otherwise my library will conflict. So instead of that, we can use the containers. Inside container is isolated, and so when we use my application version v1 inside the container, and second version we want to upgrade or test my another version, we can run the another container, and those will be the isolated, and libraries will not conflict with each other.
Thanks, Sachin. So that's all the questions we have for today.
Okay, thanks.
And thank you for that very informative session, and thank you to our viewers for joining. We run a session like this every Monday. You're welcome to join us at 6 p.m.
Yep, sure. Thanks, David.
Thank you, Sachin. Thank you so much.
Thanks all for joining the call.